Hi guys, Matthew Lanigan here with BayWa RE. We're just going to give it a couple of minutes here. We still see people logging in, so another minute or two and we'll begin the presentation. Thanks so much. Guys, Matthew Lanigan here again with BayWa RE. Thank you so much for taking the time to learn a little bit about SMA today with us and their CORE1 product. Just a couple of housekeeping notes before we get started. This will be recorded, so if you'd like a copy afterwards, it will be available. We always share any webinars during our monthly newsletter, so it will come out in the October newsletter as well. If you have any questions, I encourage you just to put them in the bottom right corner in the chat box. We will have breaks throughout the presentation and we'll do our best to answer them then. If not, we'll always follow up with you afterwards. Continuing education is a super important thing to BayWa for our staff internally as well for our customers externally. So we really appreciate you taking the time to be with us today. So without further ado, I'd like to introduce Michael Mahan, the Senior Technical Trainer with SMA.
Awesome. Well, thank you, Matthew. I really appreciate the opportunity to present to everyone. Hopefully the audience can see my screen. We're going to discuss today primarily the CORE1 three-phase commercial inverter from SMA, but also the PEAK3 1500 volt string inverter. Again, my name is Mike Mahan. A great way to follow up if you have technical questions that we don't get to during the webinar today, the training@sma-america.com email over here in the center right. Like I said, we'll talk a lot about the CORE1 three-phase commercial inverter from SMA America. I do want to mention the PEAK3 and a couple other new additions, products, and a couple features for the CORE1. So we have quite a bit to talk about, but I think we'll be able to get through it all. And as mentioned, please, any and all questions you have, put those in the chat window. I think I'll stop somewhere around here in the middle, catch up on questions for the CORE1 before diving into the new additions. If you're not familiar with the CORE1, this is what it looks like. I refer to it kind of as the dorm fridge. A lot of engineering work went into the design of this inverter to overcome a lot of common issues with commercial installations, focused primarily on commercial rooftop. We wanted this device to be, in essence, a freestanding inverter with freedom of placement on a commercial rooftop, not having installers have to worry about, do I have wall space to mount this on? Do I have to build a rack? Also, you see the DC disconnect built into the inverter. On the other side of the CORE1 US, there is an AC disconnect. So a lot of engineering work went into ensuring that balance of system components that would very likely be needed for use with the CORE1 were actually integrated into the inverter to save time for installers, to make sure that installation flow is very, very smooth. Everything that an installer should be expected to need is actually built right into the inverter, not an extra piece that has to also be mounted and wired up to the inverter. The inverter was designed primarily for commercial rooftop, but has been used to great success in carport installations, very large ground mounts as well, obviously with different mounting styles. We include commercial rooftop feet with each and every CORE1 that we ship, but obviously for different installation scenarios, people have come up with very useful mounting methods for this inverter. And the bottom of the inverter, where those commercial rooftop feet would attach, there are threaded screw holes to attach whatever a racking system or mounting hardware would be appropriate if this is not going to be a commercial rooftop install utilizing the included feet. So quite a range of applications for this device. It has been very enthusiastically utilized. In the US, we launched this product line, I believe late 2016. The model number was a US-40, and it was only a 50 kilowatt power class. Not that long ago, but probably on the order of 2.5, 3 years ago, we launched the US-41 model class. That provided one very, very nice internal feature and also added power classes to the product line. So now there is a 33 kilowatt, a 50 kilowatt, and a 62.5 kilowatt model for the CORE1 US-41. Physically, they all look the same. They all look like the inverter pictured over to the right. They all weigh the same. You would have to look at the label really to see a difference between them. The other modification going from the US-40 to the 41 model number was the integration inside the inverter of a SunSpec certified rapid shutdown transmitter board that allows for very direct compliance with rapid shutdown code requirements. So that is something that is built into the inverter. An installer does not have to add on anything, flip any dip switches or anything during installation, but it does need to be turned on during the commissioning process for the inverter if a customer wants to use it, but otherwise fairly hidden from the installation flow. In this picture, it's not as clear as other images we have later in the presentation. The black top cover of the inverter, there are actually holes in this center, and this may be where the product name came from. The center core of the inverter is actually a thermal chimney. So there are heat sink fins that protrude into that center area, and there's an airflow path up the center of the inverter. And in fact, there is a fan tray located at the bottom of that airflow path, and those fans are temperature controlled. So when the inverter's internal temperature hits a certain level, those fans will come on and begin to force air up this thermal chimney. So you have natural convection backed by forced convection for the cooling. And that's really the only preventive maintenance step once this inverter is successfully installed, to make sure that airflow path remains clear throughout the operational life, that debris has not accumulated at the bottom or on the top to block that airflow path. This inverter is a commercial inverter, so it is rated up to 1,000 volts DC. The inputs, you can see the bulkhead inputs here on the right lower of the inverter. There are 12 direct string inputs to each and every CORE1, all 3 power classes. The way those inputs are architected to come into the power conversion electronics of the inverter is there are 6 independent tracking channels with 2 string inputs for each of those 6 tracking channels. The inverter manages each of those 6 inputs independently. So in essence, it's as if you're getting 6 inverters in each box. Because there are only 2 string inputs for each of the 6 tracking channels that are all independently handled, there is no need for series fusing on the input of the CORE1. So you don't have to worry about 15 amp, 20 amp fuses. Which do I need? How many do I need for installation? How many do I need to stock for service of the device over its lifetime? There is not a need for any series fusing on the input. You have the DC disconnect built right into the body of the inverter. And on the opposite side of the US models, there is an AC disconnect as well. So you have load break rated DC and AC disconnects built into the inverter. No need to have an additional piece of equipment near the inverter wired up to it, worry about where it's mounted, it's all included. So no need for a combiner box, DC disconnects included, AC disconnect is included. Like I said, a lot of effort went to ensuring that this was very much an all-in-one, very easy to install inverter. The DC inputs, we'll talk about these connectors. These are Amphenol UTX connectors here at the bulkhead of the inverter. We include in the accessories bag shipped with each and every inverter the mating Amphenol UTX connectors and ferrules to crimp on the inverter end of the home run cables coming from the array. So installers will be able to mate Amphenol UTX to Amphenol UTX at the inverter bulkhead. And we provide sealing caps for any unused inputs. You can load the inverter unequally. You don't have to use all of the inputs, but you should be attaching something to each and every one of those plugs during installation, be it a home run cable or a sealing cap. Each of the 6 tracking channels has a very, very wide DC operating voltage window, 150 up to 1000 volts DC. Any voltage point within that window, the inverter will be making power from that input, and the 6 input channels can be working at different voltage points. So you have lots of flexibility for different string lengths, different orientations, different module types, in fact, if you want. If you're cleaning out the warehouse and have a lot of straggler modules and have 6 different strings of 6 different module types, that's fine. Those input channels, again, are handled independently by the inverter. The wide operating voltage window provides tons of design flexibility for allowing designers and installers to fill all the addressable commercial rooftop space with PV while working around skylights, stairwell access, HVAC units, code mandated walkway carve-outs on a very large rooftop array. We wanted just flexibility to fill all the addressable space with PV and have it nothing left open because of any design constraints on the inverter. While designers may not need to have 6 different string lengths coming into each inverter, having those 6 independent tracking channels, again, removes the need for series fusing, and this very wide voltage range also provides not just design benefit, it actually maximizes the benefit of our ShadeFix optimizing technology, and we'll talk about that very briefly on a few slides. But having that very wide voltage operating window maximizes the benefit of this ShadeFix optimization. And that allows for mitigation of shade or mismatch on the array without the need of any module level optimizers or microinverters. That is an inverter-based optimization. You can see a little better in this image, the holes, the perforations in the top of the inverter, and can see kind of the ribs of that fan tray at the bottom, a little bit on the dimensions and weight of the inverters. And again, all of the power classes are the same. The operating temperature goes down to -25 C, but the inverter can be exposed safely down to -40 C. If the inverter does wake up and it has not achieved -25 C, there's a very specific error code waiting for minimum operating temperature that it will display until it reaches -25 C and goes into production. The spec sheet information, we're showing the top of the spec sheet for the 3 power classes of the CORE1 US-41 line here on the lower part of this slide. Kind of boring, apologies for all of this technical information. The 2 values circled in green are the limits for the inverter that SMA cares about. This is a 1000 volt rated machine, so none of the inputs on any of those 6 input channels to the inverter, the coldest temperature the system's exposed to, should ever exceed 1000 volts. So again, that is the limit for each and every input and all of the channels on the inverter. There is also a short circuit current limit that SMA cares about. You'll notice that it says per maximum power point tracking channel / per string input, and the numbers on the data sheet are the same. You can drive each of the 6 tracking channels fully through a single positive and negative input for that channel, meaning you could use a Y branch connector to combine 2 strings out at the array and bring back a single positive and negative for that tracking channel and drive the inverter's tracking channel fully through that single positive and negative. So the short circuit current limit is the same per string input as for each of the 6 tracking channels, and that's 30 amps ISC. So these 2 values circled in green are the ones SMA cares about. If you exceed these, technically you're avoiding the warranty of the device. So these are the limits that we at SMA care about in terms of hardware. In operation, the inverter will pull a maximum of 20 amps from each of the 6 tracking channels. So that's kind of the limit the inverter will safely hold at in operation. The short circuit current limit, that's obviously a design limit, and we care very much about this, and the 1000-volt limit. If these 2 values circled in green are being respected at all times, the first row of the data sheet shows the maximum DC rating of an array that we at SMA allow you to attach to each of the power classes without any further consultation with SMA. So you can go up to a 1.5 DC to AC ratio on each of the 3 power classes without consulting at all with SMA. So you can see for the 50 kilowatt model, that is the 50 is the AC power limit coming out of the inverter. So it will never export more than 50 kilowatts AC, but you can attach to it a 75 kilowatt STC rated array, again, provided the 2 values circled in green are always being respected. And we actually have customers, this methodology for exceeding the data sheet DC to AC ratio is the same for our Sunny Boy residential inverter, our CORE1 commercial inverter, and the PEAK3 utility scale inverter that we'll talk about later. But the CORE1, I think, is the most common that we have customers actually asking about exceeding that DC to AC ratio. And certainly if you were using all 6 of the tracking channels to face an array in different orientations, you could potentially put a very, very large array to the inverter and not suffer much clipping. Or customers may have a situation where there is an AC power limit on their interconnection agreement, but there's no limit on the DC side. So they want the inverters to be working at full power for as many hours as possible every day to maximize the value of the plant, even though they face a certain AC kilowatt or megawatt connection power limit. So they can't add more inverter capacity, but potentially they can add more array capacity. Either case, if a customer would like to exceed that 1.5 DC to AC ratio listed on the spec sheet, there is a very simple exercise that we would have you go through, and this we can assist you through the apps team if you're unsure on how to use Sunny Design. But the SMA design program, Sunny Design, we would have you set up the exact scenario you are considering. So the location, the module types, the mounting method, the tilt and orientation. So you have the irradiance, the temperature, the actual design. We would run the design in Sunny Design, and there is a metric besides just the kilowatt hours per year that the system is expected to generate. There is something called the full load hours that is calculated by the program. And as long as that number stays under 2,400, SMA will approve you exceeding this datasheet DC to AC ratio. So this is the metric we would look at for consideration of exceeding the datasheet limit. Up to these limits, as long as the 2 values circled in green are being respected, you don't have to consult SMA at all. It's only going past these that we would run the design in Sunny Design, and then that full load hours metric must stay under 2,400. And what this is saying is the program is estimating that the inverter will be running at full capacity for no more than 2,400 hours in a year out of 8,670 for the year, or 8,760, I think I'm switching the numbers around. So a fair number of hours per year that the system would be under full load. So it's a pretty beefy number. And obviously this will be very dependent on the details of the actual site design. So this is, we would go to the details of that specific site design to allow a customer to exceed that 1.5 ratio. But it's a pretty beefy ratio, I think, in general. Very briefly looking at what comes with the inverter in the box, each CORE1 ships on its side on its own little pallet with a cardboard box around it and an accessories tray sitting at the top of that box. So we want this to be very easy to move around a job site, to arrange on a roof, to get it close to final placement, open the box, take out the accessories tray, take the cardboard box off of the inverter. The commercial rooftop feet are there stacked in the recess. You can kind of see the fan tray a little better here with its release handle at the bottom of the inverter. And you have access again to the bottom of the inverter body. If you're not using the commercial rooftop feet, you have those threaded screw holes there for access of attachment of whatever the appropriate hardware is. If someone's extending the racking for their array and going to mount the inverter directly to the racking, they'll have that hardware they can mount on it. And there are 4 moving handles included with each CORE1. You can see these 2 recesses in the metal case of the inverter. So 2 handles on either side can be lifted off of its pallet for final placement. And when it comes time to wire up all of the DC, again, we're providing the Amphenol UTX connectors and ferrules to crimp onto the inverter end of the home run wires. So you will be connecting Amphenol UTX to Amphenol UTX here at the inverter body. And sealing caps for the positive and negative connectors that are unused. So each and every positive and negative connector should be receiving something during installation, either being capped or a home run wire being connected to it. The device here in the middle is just a clamshell ferrite to be crimped onto the communications wire for the inverter for noise reduction. There are some knockouts here to bring communications wire in and maybe sensor wires to the communications board that lives at the top side of the DC connection area of the CORE1. Again, connection of the DC is fairly straightforward, home run conductors or sealing caps. The connectors and the ferrules that we include in the accessories bag for the CORE1 are for 10 or 12 gauge wire. You can source directly from Amphenol connectors for, I believe, at least 8 gauge, if not also 6. So if you are using a Y branch connector out at the array and bringing back a single positive and negative to drive one of the input channels and you've upsized the wire, again, what we're including in the accessories bag is appropriate for 10 or 12 gauge wires. And below all of the 6 tracking channel connectors, you have a small DC equipment ground bus bar there for connection. And you can see everything labeled A through F here. As I said, you can combine 2 strings together to bring a single positive and negative back to drive each of the 6 tracking channels. The one thing you cannot do with the CORE1 is parallel across these 6 tracking channels. So a fully loaded inverter, at a minimum, you would have 6 positive and negative home runs coming back to the inverter, and maybe up to 12. So you cannot parallel across these tracking channels. That is one of the very few things you can't do with the CORE1. We're showing kind of that Y branch connector here. So we'd have something we would expect, similar string length, similar orientation, combining the positives and negatives to bring a single positive and negative for that channel back to the inverter and simply cap the other positive and negative. But you do have that flexibility for potentially 6 different string lengths, 6 different orientations. And again, each of these tracking channels is being operated independently. These could be different module types. As long as you are remaining within that 150 up to 1,000 volt DC operating window, the inverter will be making power from each of these 6 tracking channels, and it's operating them all independently. I want to segue a little bit into discussion of rapid shutdown and ShadeFix. So again, ShadeFix is an optimization technology built into SMA's residential Sunny Boy line, as well as our commercial CORE1 line. So we're showing both icons here. The discussion is the same for both product lines. We at SMA, we're celebrating our 40th anniversary this year. We feel we are pretty good at building very full-featured inverters, and we think it is best for the system to leave as much functionality as possible in the inverter itself. If something goes wrong in a system, a service technician has to go out to visit the system, we want them to be able to access the inverter to resolve the vast majority of those issues. The inverter should be in an easier place to access in most scenarios rather than having to dig apart the array to replace a failed module level power electronics device. So as much functionality as we can leave in the inverters, we would like to. And that's the whole point for ShadeFix. This is an optimization technology built into the inverter that drives the operation of the array to maximize energy production, even in conditions of partial shade or mismatch, without the need of any module level power electronics devices. You may see out in industry, and I saw, unfortunately, a PV USA magazine article that parroted this incorrect statement very recently, that a string inverter system, the array has this Christmas light effect where one module fails, all of the rest of the string has to fail. And so a string inverter is limited to only producing as much electricity as the least productive panel. And ShadeFix simply prevents those statements from being true. So it's a shame that I think our module level power electronics competitors keep allowing that myth to be propagated, and that string inverters will always suffer this feature. And again, that's what ShadeFix is all about, preventing that statement from being true without the additional cost of all of these complex module level power electronics devices that may be stretching into the dozens, if not hundreds, or even more than 1,000 for a large commercial site. The Academy, I am happy to talk about the gory technical details of what ShadeFix is doing during its operation, but I think that is generally way past the desire of any potential system owner. So if you have a desire to discuss the details, I am more than happy to do it. The graphic on this slide comes from a white paper that we have posted on the SMA-America.com site discussing ShadeFix. I think this graphic is the appropriate talking point for an installer discussing, or a designer discussing with a potential system owner, the benefits of ShadeFix. The takeaway of this diagram is that the SMA ShadeFix optimized inverter can outperform conventional DC optimizer system. And by outperform, I mean higher yield, higher AC kilowatt hours out of the inverter in the vast majority of shade scenarios versus those DC optimizers. And you may say, why? Well, the ShadeFix optimization is a periodic optimization built in the inverter. It does not require devices behind each and every module. And those standard DC optimizers, they're always pitched as providing the ability to squeeze a few more DC watts off a shaded module. But what is often left unsaid is those devices will always be boosting or bucking their module voltage, because the architecture, the string inverter in that architecture, is demanding a constant DC voltage, independent of the module type, independent of the string length, independent of the time of day, time of year, or location of the system. So those optimizers are always consuming DC watts every second the system is in operation to boost or buck module voltage, whether or not they're providing a shade or mismatch benefit. So the net power draw of having those DC optimizers consume DC watts every second the system is operating outweighs the benefit they provide, except in the most severe shading scenarios. So having the periodic optimization based in the inverter that is not consuming DC watts, whether or not there is shade, yields higher yield, higher AC kilowatt hours out of the inverter. And it's important that customers understand AC kilowatt hours out of the inverter is the only thing that pays off the solar system. That is what spins the meter backwards, banks credits for the system owner, offsets their utility bill. DC watts being squeezed off of a partially shaded module does nothing for the customer if there are fewer AC kilowatt hours coming out of the system. So the yield metric, the important thing, is AC kilowatt hours out of the system. The data for this graph, there was a year-long study performed by a professor in the University of Southern Denmark comparing 3 identical systems, an SMA ShadeFix optimized system and 2 DC optimizer systems. Identical array capacities, identical AC output capacities of the inverter. The systems were run for a full year with various shade scenarios, some just environmental shading, some artificial shade objects were thrown in for several weeks. And over the whole year, the SMA ShadeFix system produced the most AC kilowatt hours of the 3 systems. But all that gory detail, I think, is well contained in this graphic, very easy to understand, and kind of showing that ShadeFix can outperform in the vast majority of shade scenarios. And if the customer says why, the discussion of those DC optimizers are consuming DC watts every second the system is operating, whether or not they're providing a shade or mismatch benefit. And that continuous draw outweighs their benefit for the vast majority of shade scenarios. Only when there's such severe shading that their benefit finally outweighs that continuous power draw do you get a net yield benefit from the DC optimizer system. There's also a truck analogy that we have, or automotive analogy, I should say, that we have in the white paper that I think is also very good. You can think of that standard DC optimizer system as a vehicle with always on four-wheel drive, where you'll get the best traction at every wheel, but the overall system efficiency, which in the automotive world would be miles per gallon, and the solar equivalent, it would be AC kilowatt hours out of the inverter, generally takes a hit for having that always on four-wheel drive. Whereas a two-wheel drive vehicle, or maybe a vehicle that has a two-wheel drive, think of it with a way of checking to make sure you're on the highest traction path to your destination, the overall efficiency, miles per gallon for the automotive equivalent, AC kilowatt hours out of the inverter for the solar equivalent, will be higher for this scenario. And also, the having as much functionality left in the inverter as possible reduces complexity out at the array. Having DC optimizers touching each and every module that have to have circuitry to be able to boost or buck voltage, and that will be utilizing that circuitry all of the time the system's in operation, means that there's a far more complex system, and those power conversion devices are in the harshest environment of the system and the hardest to access should something go wrong. So we at SMA want to leave as much complexity in the inverter as possible. Something goes wrong, it should be very easy for the installer, the repair tech, to go to where the inverter is and perform service there, rather than having to tear apart the array. So we want to leave as much complexity in the inverter as possible for the overall reliability of the system to be as high as possible. Well, the flip side of that coin is that lots of areas of North America now require something touch each and every module to comply with rapid shutdown. So again, SMA is saying even if code is requiring something touch these modules, we want them to be as simple as possible, to be in essence module on-off switches. And that's what these SunSpec devices can provide. So we mentioned that the CORE1 US-41 line has an integrated SunSpec certified transmitter built into it. The other half of the puzzle for utilizing SunSpec for code compliance is to have a receiver element at the array that is listening for the signal that the transmitter in the inverter generates. And these SunSpec receivers are very low complexity. They don't have to boost or buck DC voltage. They certainly don't have to convert DC current to AC current. They are simply listening for a signal generated by the inverter-based transmitter. If it's present, they allow their modules to operate. If it's not, they isolate their modules from the system, the string they are part of. They don't break the string. So in essence, they are simple on-off switches. So far less complexity, even if code is requiring them. And we showed carport installations, ground mount installations with the CORE1. Those may not be the vast majority of install scenarios, but quite often those installs may not require rapid shutdown. In that case, you simply don't use the SunSpec receivers at the array. The inverter does not need them to operate. ShadeFix is built into the inverter. You get all of that energy optimization, whether or not the rapid shutdown receivers are being used. So you can tailor each installation specifically to the code requirements. Those receivers are very easy to install. They are not providing module level data back to the inverter. So when you are commissioning the system, you don't have to wait for them all to report in. You don't have to scan the barcodes of all the devices and create that module layout map for monitoring. So it's a much simpler, faster install, far less complexity strewn throughout the array, which again, to translate to higher reliability. And you have the ShadeFix optimization built into the inverter. So we're aiming for very, very fast, low cost, high reliability, easy to install, and high yield PV installations. Again, kind of discussing what SunSpec rapid shutdown is providing for code compliance. If you're not familiar with the SunSpec Alliance, it is an industry alliance of over 100 companies, and SMA is one of those companies. And they are kind of chartered with solving industry-wide problems. So they tackled first interoperable communication between hardware of different manufacturers. So they came up with a subset of the Modbus protocol called SunSpec Modbus. Then they moved on to solving rapid shutdown. So they produced this open standard. So they published a standard that people can comply to that is a power line communication signaling protocol, and will go between a transmitter somewhere in the system and receiver elements at the array. And as long as the receiver elements see that power line communication signal, they are acting kind of as an on switch for their modules, but they're not boosting or bucking DC voltage. They're not converting DC current to AC current. Very, very simple devices. Whenever that signal goes away, the receivers recognize the signal is no longer present, and they will isolate their modules from the string they are part of. They don't break the string. They will simply have a very low output voltage whenever they do not recognize that power line communication signal being present. So in essence, they are on-off switches for the module. Again, the SunSpec Alliance published their power line communication protocol. So it's an open standard that anyone can build products that comply with, and they can then submit those products to the SunSpec Alliance for testing. That is what SMA has done. So the transmitter boards in our CORE1 US-41, as well as our Sunny Boy line, have been certified by the SunSpec Alliance to be in compliance with their open standard. So the transmitter is in the inverters for the SMA system. When they are turned on during commissioning, they begin to broadcast that keep alive or permission to operate signal. That's what that power line communication signal really is, on the DC conductors between the inverter and the array. So there's no additional communication channel required. That signal is sent out to the array. The receiver elements, the SunSpec certified receiver elements, will recognize that signal and allow their modules to begin participating in the system, but it will be at the point the SMA inverter dictates via ShadeFix. So these are just on-off devices for their modules, and again, provide code compliance. All of the requirements for rapid shutdown can be met, along with some adequate labeling and decision of what the initiator for rapid shutdown should be. The way we have set up our inverters, once the transmitter board is turned on during commissioning, the array goes into operation. Once that happens, the inverter will take loss of AC power on its AC terminals as the signal to stop transmitting from the board out to the array. So that keep alive signal will stop. Very quickly, the receiver elements at the array will see that the signal has gone away and begin isolating their modules from the string they are part of, taking the array into shutdown and meeting all of the voltage requirements of rapid shutdown. So aiming for a very, very simple way to trigger this, any AC disconnect upstream of the terminals of the inverter, as long as it's adequately labeled, can act as the rapid shutdown initiator. For a single inverter, it could be the breaker for the inverter. Multiple inverters, maybe there is a collection panel for the PV system with a main disconnect. That main disconnect could be the initiator, or it could be the whole service disconnect. Anything that will remove utility power from the inverter's terminals can act as that rapid shutdown initiator. In this diagram, we're showing the JMSF SunSpec certified rapid shutdown receiver being used. This device is not made by SMA, but there is an SMA part number for it. So if you talk to BayWa, ask for the SMA price list, there actually is a part number on the SMA price list for this specific SunSpec certified rapid shutdown receiver element. So we did that to make sure that folks could source these very easily. Even though it's not an SMA part, it has an SMA part number. Pairing this device with the CORE1 is all that is required. And again, the JMSF device is a one module input device, so there would be one of these for every module in the array. No matter how many modules you have, how many inverters you have, you would equip each with this device. Again, it's very simple to add on to these modules. You turn on the transmitter during commissioning, and you're done. That is all that you need to do. If folks are very savvy with the specifications of SunSpec rapid shutdown, the standard says a minimum of 6 to a maximum of 30 devices per string, and I think you can have up to 10 strings paralleled and still quote unquote comply with their standard. We've gone a little further. We want to make sure that when the system's in shutdown, we'll have enough DC voltage from the array, even in shutdown, to ensure that the system will start back up correctly. So while there are 6 tracking channels, potentially 6 different string lengths coming to each CORE1, we're saying one of those strings need to be at least 10 module device pair long to ensure that there's enough DC voltage on at least one of the inputs to boot the system back up. So at least one string or channel coming into the CORE1 needs to be 10 modules long. The other ones could be shorter. Generally, that's not much of a concern on our commercial systems, but I wanted to include that. It's slightly different than the published SunSpec standard. The JMSF device, if you haven't seen it, again, a very simple device meant to add on to a PV module, connect to the PV module junction box leads, and then build your code compliant string with the output leads. So attaching this to the module kind of gives you that rapid shutdown compliant module, and then you build the system as before, turn on the transmitter in the CORE1. The JMSF device, it handles modules up to 600 watts, up to 60 volts and 15 amps. So there is not a residential versus a commercial version of this device. If it works with the module, you can use it with either of our inverter lines that have that SunSpec transmitter built into it. And there is an additional, and I'll start some nuance here, SMA Compatible Device. The SunSpec Alliance takes care of certifying receiver elements like the JMSF or this AP Smart RSD-S-PLC device to make sure that they correctly recognize that power line communication signal and act appropriately based on whether it's present or not. So that takes care of all the rapid shutdown compliance. SMA goes a step further, and we have a compatibility testing for these SunSpec certified devices to make sure that all of the SunSpec certification took care of rapid shutdown, that while the rapid shutdown is being handled, nothing else, no other safety features of our inverters, no other operational features of our inverters are impacted by that rapid shutdown signaling. So there is in fact an SMA compatible list or an SMA approved list of SunSpec certified receivers. Currently, the two commercially available devices are the JMSF and this AP Smart RSD-S-PLC device. This device, again, just like the JMS device, is not manufactured by SMA, but for this device, we are not providing an SMA part number. So these would be sourced directly from AP Smart.
And Mike, we actually stock these. We have heavy stock on these, so they
Awesome.
are stock in our 4 locations across Canada.
Awesome. And so they're similar in a lot of ways to the JMS device. The one thing is they do have a slightly higher operating voltage range. So either certain larger modules or those people facing very cold minimum temperatures, this might be more attractive than the JMS-F device. Very small, very simple. Again, just like the JMS, there are clips on the backside. This is meant to mount to the module frame, short leads attached to the module input leads, and the longer leads that build your code compliant string. The device that we went through compatibility testing with, as the part number starts 415, and this was a nuance that months ago the AP Smart had transitioned from a 405 to a 415. I don't think you should have any issue with this being what BayWa has stock of. That part number, the serial number I have is 6051. That's on the little label here, but the part number, there are 2 choices that are appropriate. The one that ends in 002 is, I think, their standard product that has true MC4 connectors on both the input and output leads. It is possible to source from AP Smart customized connectors. I'm not certain what sort of lead time that would entail, but if you know you have a ton of modules that may not be MC4 connectors, it's possible to get those customized. But the common off of the shelf device has MC4 connectors for both input and output, just like the JMS device. So again, either of those 2 devices, and I want to spend a little more time on this SMA approved list. What is it? Why did we do it? Again, SunSpec certification handles all of the testing for the rapid shutdown functionality and make sure that works correctly, complies with the SunSpec standard. The SMA approval testing is ensuring that no other functionalities of our inverters are impacted while that rapid shutdown signaling is going on. So there is a document on the SMA America website that is this SMA approved list. We started with the SMA TS4-R-F-42. That was an SMA product. It is no longer available. That was the third device on this list. So the two commercially available devices on that SMA approved list are the JMS-F and the RSD-S-PLC. I want to emphasize this because there's been a lot of customer confusion. The Tigo TS4-A-F or the A-2-A-2F, neither of those devices is certified by SunSpec. Only devices that are on the SunSpec certified list are going to go through SMA approval testing. So neither of these two devices is on the approved list. SMA supports only combinations of devices off of the approved list with our inverters with the SunSpec certified transmitters, so the CORE1 US-41 and the Sunny Boy US-41. So again, I'm emphasizing this because there's been a lot of customer confusion and a lot of finger pointing. Should something go wrong with a non-approved combination, we would say, hey, contact Tigo for use of this non-approved combination. They would say, no, this is, a kind of a cycle of finger pointing that we do not want customers to experience. So again, SMA is supporting devices off of the approved list only. If there are any other questions on the CORE1, this may be a good time to throw them out. There are two things I want to talk about as added features for the CORE1 before spending a few minutes on the PEAK3. These two new features for the CORE1 have actually been unlocked by a firmware version. So the firmware version, this firmware version is on the website. It should be on the automatic update portal. So if you've registered a system to the Sunny portal and turned on automatic firmware updates, this should have been migrated to any US-41 unit out there. This firmware has two major upgrades for the CORE1. The first one, and one I find very exciting, is the ability for anyone to trigger in the user interface of the inverter an IV curve tracing test. So log into the inverter. In the user interface, you can force the inverter to do an IV curve trace on its 6 tracking channel inputs. Takes about 20 seconds per channel, so that's roughly 2 minutes to do the test. It stores several hundred data points for the curves for each of those inputs. If the sensor module accessory card has been installed in the CORE1 and temperature and irradiance measurements are available there at the inverter, those values will be logged with the curve. So you'll have the irradiance and the temperature to be able to benchmark the performance against STC or whatever your other historical performance curves are. So without having to shut the system down, without having to tear apart the array, remove any module level power electronics, put all the modules in series to do an IV curve trace, you can have the system wired as it is during operation, trigger the IV curve trace, and then be able to archive those curves year after year to be able to benchmark performance. So this is the location of the technical document that talks about the curve tracing. This is on the website on the product page for the CORE1 right now. This will work even if the array is equipped with the SunSpec rapid shutdown devices. The thing is, if you drive that IV curve from all the way from VOC down to 0 volts, lower voltage, you'll begin turning off those rapid shutdown receivers. They had a minimum operating voltage. Below that, they'll begin to shut off and you'll get meaningless data. So when the SunSpec transmitter is on, you won't have curve data below 230 volts DC. So what we're showing in this diagram, the curves are going from VOC all the way down to 0 volts. So with rapid shutdown equipment, draw a line here at about 250 volts. I don't believe any data will actually show up. If it does, it should not really be considered meaningful. So in the user interface of the inverter, and this is what we're showing, we've logged into that self-hosted user interface. You can trigger a new measurement. It will do the 6 curve traces. So give it about 2 minutes. I don't believe you'll see anything like a countdown timer on the screen. So just give it its time to run. And when it's finished, the new curves will appear in this screen. When the information is there, you can export the graph as a PDF, or you can export the data itself as a CSV. Only one set, the most recent set of curves, is stored in the user interface of the inverter. So if you want to archive these, to have annual comparisons or 6 months comparison, whatever you want to do, go ahead and export the data once the new curves appear. Take that, store it. Again, if you have temperature and irradiance measurement for the inverter, those will be displayed. If you have one inverter that has that and you do all of the curve traces for, let's say, 6 CORE1s fairly quickly, you can probably use those measurements for all 6, but they will only be logged for the inverter or stored in the export in the inverter where that sensor module accessory card is physically attached to. But I think this is really nice. Again, does not require disassembly of the array to have this be performed. Again, you have the inverter working when you click Start New Measurement. So don't turn anything off. The inverter should be in operation. AC and DC should be on. Go ahead and start new measurement. Again, it'll take each tracking channel offline while it performs the curve. So roughly 2 minutes, you will be taking off 1/6 of production and kind of driving it to different spots. But you'll get this data without having to tear apart the array, which I think is very, very useful. The other functionality unlocked in
a couple of questions have come in here. One is the Amphenol UTX connectors are officially discontinued. They've stopped the supply as of June 31st. Does SMA still equip their inverters with them?
So the Amphenol UTX connectors, yes, will be used to the point of, and again, this is, I don't know when a transition will be made to a different connector, and I'm unaware of what that new connector will be. I think the reason we chose the Amphenol UTX to begin with is that was rated up to 1500 volts all across the world, not only UL markets, but IEC markets as well as Japan. So I'm not sure what we will move to. All of the SunSpec devices that we talked about, the standard versions of them have true MC4 connectors on them. So it may be easy for UL markets to have the MC4 connectors. So I don't know what that new connector will be. Rest assured, though, as we do with the Amphenol UTX, we will be providing the mating connectors for whatever is there on the body of the inverter, as well as ferrules to connect on those home run wires completely. So I'm sorry I don't have a better answer for that, but definitely when it's clear what we're moving to, we'll definitely include that in the presentations. But it would be one of those things, whatever we're moving to, we're going to provide the mating connectors for that home run, the inverter side of the home runs as well.
Sure. And then a couple more here. What are the options for, what are the options to fix the inverter feet to the roof in windy areas?
Yeah. So again, we would have, suggestions perhaps from the application engineering team. Definitely down here in the United States, you have certain areas, like you say, East Coast, maybe high wind areas, West Coast, maybe seismic areas where a physical attachment or, penetration into the roof and then tying into the inverter body is required. So that's not something SMA would provide, but we can definitely, I think, through the apps team, provide guidance on what customers have used for maybe permanent, anchor into a rooftop, or like you say, either ballast loading, attaching to the racking for certain wind loads. Past a certain point, you might have to have a physical attachment as well. So it wouldn't be an SMA part number, but I would, encourage anyone who has that question to forward it on, and we can definitely get them in contact with like the apps team.
Great. Does the CORE1 require a neutral?
It does not. So I don't have any wiring diagrams in here, but on the AC side, you have the 2-inch knockout, and you have conductor terminals for line 1, line 2, line 3, and neutral. There is, in fact, a jumper that bonds the neutral terminal to the body of the inverter installed at the factory. The inverters, and this is the important statement, each and every CORE1 US must connect to a 277/480 grounded Y service. In operation, it does not burden the neutral with any current. It is using the measurement at that neutral terminal as a reference to ground. So while it must connect electrically to a 277/480 grounded Y service, it does not need the neutral to be brought to it to operate. So it's completely up to the AHJ. If you don't have to run the neutral to each and every inverter, don't. Save yourself a bunch of money. Leave the jumper installed. If you are required to pull the neutral to each and every inverter, remove the existing jumper because the terminal is certified only for one conductor. So if there's follow-up on that, I apologize for time. I didn't have those slides in this presentation, but hopefully that was a clear enough answer.
Sure. And in regards to the inverter and the mounting of it, does it need to be perfectly level when it's mounted?
It does not. I think we have in the installation manual certain degrees, and it's pretty low. I think 3 to 5. That is one. I think if you have a customer who has a concern, talking to the apps team, the product manager, kind of the statement is you could have the inverter mounted at a 90-degree angle. It will operate. Obviously, you are adjusting the airflow path for the inverter, and so there may be some operational impacts. So it is a question of what an AHJ would want, I think, in terms of making sure the inverter does not move around, subject to its physical impacts during operation. The SMA side is far more forgiving, and it's just understanding that the more you tilt that, the less effective the natural convection will be at cooling it. So again, that's not a definitive answer, but I think anybody who has a concern consulting with the apps team is probably a great first step.
Great. Hardwired communication options are ideal, but do the CORE1 inverters offer wireless communication options? Existing project with existing power conduits, but not the communication conduits. Carport arrays, parking lot has already been paved.
It pains me to say yes, there is Wi-Fi built into the CORE1s. And the reason it pains me is because obviously you're going to then have lots of metal lids on the CORE1 carports. You're going to have lots of metal stuff all around this device. The Wi-Fi functionality is there in the CORE1s. It is a 2.4 gigahertz Wi-Fi channel only, but it has the ability, yes, to communicate via Wi-Fi built in.
And is it 1,000 volts input per MPPT or 1,000 volt total between all 6?
Any input, so any string, any channel, each and every one can go up to 1,000. None can exceed 1,000.
Are there string level rapid shutdown receivers that work with SMA inverters?
I would have to go back and look. Yes, the CORE1 US-40 line, we had certified 2 products. I would even have to check to see if they're still in production. I would say whoever asked that question, if you could please follow up with me directly at the training@sma-america.com email, and I can get you more information. Since most areas in the US are on 2017 or higher rapid shutdown for a while, we've kind of gone away from that string level shutdown. So I can provide what was certified, and we can inquire with the product manager on anything newer.
Great. And is there 122.08 volt or 347/600 volt connection options?
No.
Okay.
Sorry, that's an easy answer.
Yep.
Oh.
And last question I see here at the moment, when you say max ISC, are you meaning the max of ISC times 125% or max ISC?
We mean max ISC, but I think if you talk to our apps team, we would recommend taking that 30 and divide by the 1.25 and have the data sheet ISC not exceed that value. So that would be lower. So if that was clear, generally we'd recommend dividing by the 1.25 and having that ISC be the data sheet ISC that you're considering, modules you're considering, be lower than that number. Again, for us at SMA, that number is all we care about. But because we can't control site conditions, if it's a bifacial module, we don't know the backside gain, we generally recommend utilizing, dividing that 30 by the 1.25. Okay, I will close up on the AFCI option, and I will at least start on the PEAK3. I know we're kind of running up against time. The other functionality unlocked by the latest version of firmware for the US-41 models of the CORE1 is the ability, now that UL 1699B is a full published standard, it does allow in certain low energy, very quickly extinguished arcs, if an inverter, let's say the CORE1, detects an arc, there is now an allowance with the new standard for automatic restarting. Again, if that arc energy is under a certain threshold, if the arc can be extinguished within a certain time, then automatic restarts are allowed by the standard. That functionality is now allowed in the firmware, but it is not turned on by default. So the CORE1s with the new firmware still will require manual restart for arc events, but it is now possible to go in and choose with AFCI on to select this yes, but without permanent operator inhibition. And in clear translated language, what that means is does not require manual restart if the code allows an automatic reset. So there will be an interruption of power produced, but it is possible to have the inverter attempt to automatically restart from, again, low energy, quickly extinguished arc events. So again, it's not on by default, but this functionality is there once the firmware is updated to 3.12.21 or higher. Okay, if there is time, I do have 3 or 4 slides on the PEAK3. I just want to introduce this device.
Sure.
It is functionally and architecturally vastly different than the CORE1. This device is a 1500 volt string inverter, and it is targeted at large scale distributed generation ground mount applications. The UL listed devices, there are 2 power classes for the PEAK3, either 150 kilowatts or 125 kilowatts. The difference between the 2 models is the AC output voltage for the device. The 125 kilowatt unit is a 480 volt 3-phase output, so similar connection to the CORE1 that we talked about. So this is very useful in the US for some building tie-in systems, so large co-located ground mount systems for a large facility. The 150 kilowatt unit is a 600 volt 3-phase AC device. Again, this is kind of in our utility scale portfolio. While it is a simple off-of-the-shelf device string inverter, unlike our centrals that are very customized, this device is architected in a similar fashion. It is a single tracking channel input inverter, so that we're assuming that there will be a large amount of space to have no concern with a large number of equal length, equal orientation strings coming to each and every PEAK3. So there most definitely will need to be a combiner box used with these inverters. So there's not a combiner box included, but it is a single tracking channel inverter. And again, we're aiming for less flexibility on design as a trade-off for exceedingly high efficiency. So very, very high. Again, these are weighted efficiency, not peak efficiency numbers for the 2 power classes. So very enthusiastically adopted inverter for projects up to, I think, our current plant size limit for the PEAK3, or the highest capacity one that has been installed with the PEAK3, is 70 megawatts. And I think in early 2022, we're going to go past 100 megawatt plant site with the PEAK3 inverter. So it has been rather enthusiastically adopted to very large megawatt sizes. The inverter, again, single tracking channel. We have the 1500 volt DC limit, and there is a 325 amp short circuit current limit for this device. With those 2 numbers being respected, you can go up to a 1.5 DC to AC ratio. And it's a similar metric. If a customer wanted to go past that spec sheet DC to AC ratio, we would do the design in Sunny Design. And we, in fact, have just recently increased for only the PEAK3 the full load hours that would be allowed. It is now a 3,000 full load hour limit, not 2,400 like the CORE1. And so that's, in essence, 8 hours every day of a whole year where it's running at full capacity. So 3,000 peak load hours is quite a bit. So it is a workhorse for those large ground mount arrays where people are probably butting up against an AC connection limit, but want to load the inverters quite heavily. So definitely a different application niche than the CORE1. In the US, 1500 volts is not allowed on rooftops. It's my understanding that it may be allowed up in Canada on rooftops. This is not intended to be a device used with rooftop arrays. There is not AFCI in this device, and there is no rapid shutdown transmitter. So again, this was intended for large-scale ground mount systems that did not have to comply with those rooftop operation requirements. So apologies if 1500 volt string inverter with a 600 volt three-phase AC output looks very attractive for certain rooftop applications. That is not what this device is intended for. The general layout we would expect for the PEAK3, while it is possible to have for a very large PV array field, the inverters spread throughout the array field, we almost always recommend to customers that you adopt a centralized plant design. That is, while you have smaller power conversion units, you still lay them out as you would a central inverter with very few spots throughout the array field where you're consolidating the inverters. Obviously, there will be combiner boxes. Those can be out at the array, but then you have the longer runs from the array to the inverters be the DC side, the higher voltage side. Even the 600 volt units, the DC side should be higher voltage than the AC side. Run the power for longer distance on the higher voltage, thus lower current, lower loss line, and have the AC runs be as short as possible. They'll be from the combiner box, the positive and negative. You have at least 3 conductors on the AC side, have those be as short as possible, save conductor cost, save losses. Having them located centrally also provides very easy wiring of communications. You know, like you said, if the site has already been laid out, somebody forgot to accommodate the communications cabling, very simple to accommodate after the fact if all of these inverters are located in only a few spots throughout the plant. Whereas if they're scattered throughout the array field, it becomes much harder to go back and trench out additional conduit run. Furthermore, having the inverters very close to the point of tie-in, generally this is the point where energy is metered and the customer makes revenue. Once power leaves the inverter's terminals, any losses that are incurred cannot be overcome. The inverter can only output its nameplate, and there is no way to overcome losses that are incurred after those terminals. Whereas coming into the inverter, we just mentioned the DC to AC ratio threshold. You can potentially have additional array capacity to overcome any losses on the DC side and still allow the inverter to be exporting at nameplate. So shortening these runs to the extent possible, having the inverters be able to run at nameplate provides maximum revenue possible for the system owner. And setting up plants like this is very straightforward to come to what is not a very large 2 megawatt block. The 125 kilowatt unit, again, a 480 volt transformer, pretty straightforward. 1, 2, 3, 4. You have 8 125, so you have 1 megawatt here and 1 megawatt here. AC collection panels for the groups of inverters. Lots of areas you'll have DC disconnect needs, and so some folks have asked about combiner box DC disconnect at the inverter, combiner box at the array, DC disconnect at the inverter. We're investigating DC disconnect enclosures that would work with plant a layout like this, where each group of inverters would also have DC disconnection options very, very close. 690.15, you may be required to have disconnecting means, both DC and AC, within 10 feet of the inverters. So having the ability to place these inverters very close to each other. All of the airflow in the inverters is from the back top down. So there is the ability to place them very close together, side to side. So can have setups like this to large plant size, complying very easily with code and scaling up to very, very large blocks. So An exciting device, again, really aimed at a different market segment than the CORE1, but a common off-of-the-shelf inverter to scale up to very, very large megawatt plant size for these ground mounts. And a few other options, again, using the 150, 20 inverters get you that 3 megawatt plant size. So similar layout, disconnect, AC disconnect in the racks or rows of potentially back-to-back inverters with your transformer close by. Okay, I know I have run over time. I had a screen on our updated app for Sunny Portal and a little slide on our Smart Connected program, but I want to find out if it is best to wrap up right now. We could just provide the slides, or if there is time for me to continue.
If you want to continue, we're fine on the BayWa side. So folks who want to stay on, please stay on. Otherwise, feel free to drop off. There was one question about the PEAK3. Does it also have ShadeFix?
No, it does not. So again, we're expecting this to be a big array field where there is no concern for shading or uneven soiling on the array, that you have pretty much a very uniform array. So we're not even including the ShadeFix. We're aiming for just maximum efficiency, have this device be tracking what is assumed to be a single maximum power point for its whole array. A great question, though. Okay, I will be brief on the other topics. The Energy app has been launched, I think it was a couple of weeks ago in North America, and I think all of South America as well. This has been available in Europe for a while, but it's just gone live here. This is a replacement to the SMA Classic Sunny Portal app, but it also covers plants that are registered in the new NXOS portal. This does not replace the web access to either the Classic or the NXOS portal. This is intended to be an app for end system owners to be able to visualize their systems. So a much modernized, I'm very happy with the look and feel of this app, but it is available now. If you have customers who use the Classic Sunny Portal app, be aware when they log in, they should be receiving a warning that it will be turned off very shortly, as of November 1st. So the Energy app is available for free download for Android or iOS devices, and it will be the replacement. It will be the replacement when the Classic Sunny Portal app goes dark. Again, this will show plants on either the Classic or the NXOS Sunny Portal. If you are an installer that has plants on both, when you log in using those Sunny Portal credentials in the Energy app, you will see all of your plants on both portals in this little pull-down menu. This is intended, again, to be kind of the system owner's view into their plant production. We will be launching another app that is installer focused, maybe later this year, but very likely early next year, called the 360-degree app. So this should be considered the system owners, the easy mobile visibility into their system. Again, intended to work with the web portals for the Classic and NXOS Sunny Portal, not replace them. With storage, again, very nice look and feel, quite a bit of information that can be provided to system owners. So I very much like this. Anybody who uses that Classic Sunny Portal app should be aware of this, but make sure that folks know that that Classic Sunny Portal app is going to go dark very, very shortly, only about 3 or 4 weeks. The service side of the business, I wanted to make sure folks are aware, I did not mention it. Our Sunny Boy and CORE1 inverters start with a standard 10-year warranty that can be extended to 15 or 20. The PEAK3 falls in that utility window, and so like our Centrals, it carries a 5-year standard warranty. You can still buy extensions all the way out to 20, but it starts with that utility standard 5-year, and you can buy the 5-year increments. If you buy the JMSF devices through SMA, that carries a 25-year warranty, and even though it's not an SMA part, your first point of service contact will be SMA. The online service center is a resource that anyone who is working out in the field with SMA inverters should be aware of. This online portal, my.sma-service.com, is yet another way to interact with the SMA service team. We have our phone support, our email support, but this is a portal where folks can register. Once you are registered on the online service center, you can log in and see all of your service tickets with SMA. Those that are open, those that are in progress, those that have been resolved. You can create new service tickets. When you create a ticket, you can attach documentation. So if you've done the first few troubleshooting steps and taken pictures of your multimeter or a picture from the user interface of the inverter, you can attach that to the service ticket so that when an SMA service tech opens that case, they'll see that you've done steps 1, maybe 2, and can go ahead and proceed to the next item down the troubleshooting list. So aiming to provide yet another way to interface with the service team kind of on your own time and in a way that hopefully can speed up resolution of any service issues you have. So very, very highly recommended to poke around on the online service center. It also provides access to, through the search field at the top center. Even if you haven't logged into the online service center, you have access to this search area. And that's searching a bunch of SMA service related documents that may not be very easy to find on the SMA-America.com website directly. So very, very useful. I recommend anyone who works with SMA equipment to poke around on the online service center and register for an account if you have not. Smart Connected is a free program. It's been around for a while now, but sometimes slips through the cracks. People are not aware of this. Anytime a customer has a system with SMA inverters registered to the Sunny portal, our monitoring site, you can enroll for free in the Smart Connected program. Enrolling is asking having SMA service begin to proactively monitor and respond to any warning or error messages that the plant sends to the Sunny portal servers. So if it's a warning message, SMA service can see that maybe via email, say, hey, we saw this warning. This is indicative of X, Y, or Z. Maybe it's just a communication cable being unplugged, or maybe it's something to investigate. They can provide proactive diagnostic support via email. If it's an error on one of the CORE1s on the site and service knows, 9 times out of 10, the final resolution of this error is to ship a replacement inverter, or if you're certified for board swap, to send a replacement board for the CORE1. They can choose to proactively ship that replacement device without anyone having to go to site to trigger the RMA, to go back to their shop to wait for the replacement device to arrive, to go back to the site a second time to do the swap. So potentially removing even one whole truck roll from inverter replacement service cycle. All of this, again, is for free as long as the plant is registered on the Sunny portal. That can be the classic or the NXOS Sunny portal. And we've opened the backward-looking window. We used to give you just 90 days after plant registration on the portal to sign up for Smart Connected. That is now backwards-looking 2 years. So plants that have been on the Sunny portal since November of 2019 are now eligible to enroll in Smart Connected. And that covers continental US as well as all of Canada. So that is available to customers. If you're not aware of it, again, that window opening, you have plants that have been on either portal for a while now can enroll in Smart Connected. So I think a very, very useful service program. Again, no cost add, does require the devices be registered to the Sunny portal. Once that is done, it's free to enroll. Okay, that is all I had to present. I don't know if there are any other questions that have rolled in or questions for the Energy app or Smart Connected or the online service center, but thank you, everybody.
Great, thanks, Mike. Really appreciate you taking the time to educate us. Just a couple of things before we go. We do have lots of SMA products in stock in our 4 warehouses across Canada. If you have any follow-up questions, please reach out to your inside or outside sales reps. They'll be super happy to help you out. This has been recorded. The recording will be shared in the October newsletter that's going out. If you need a copy sooner in the next day or so, please reach out to your rep. Our web shop is a great resource to go find all the specs, the install manuals, the warranty docs, stocking levels, and pricing as well. So SMA has been a great product. This is my 20th year in solar. They are bulletproof. I've seen very few issues, if any, with them. And there's very few products out there that have actually outlasted the warranty of the inverter and are still running fine. So super awesome product. And once again, just thank you for everyone for spending the time to learn a little more on the products with us. Have a great day, and I hope everyone's staying safe.
Thanks again. Take care, everybody. Bye-bye.